Hello, let's continue our Sudoku adventure with Kite by Palfly Kampling. So we have normal Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have remote sum cages. So that means that whatever digit we put in a cage, which the example says 2 here, that means that we have a digit that's 2 away, vertically or horizontally. So either here, 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 or here. And that digit will sum to 8 in this case with the 2. So we need a 6 somewhere. So a 6 here would work. So you take the sum here. So you take the 2 that was placed in this box, sorry, in this cage. Take the 2 in this cage, go 2 cells away in some direction, vertically or horizontally. And then we chose this one. And then we have to put a 6 there. So that the 2 digits sum to 8. And the 8 is the top left corner digit. So these would sum to 10, sum to 6, etc. So hopefully that's clear. I think it's a rule that's harder to explain than to understand. But yeah, so that's it. Those are the rules. Obviously, you need to logically figure out how these work. You can't just randomly do 2, 6 and expect the puzzle to work. There's only one solution to the puzzle. Hopefully that's clear. We're not just randomly picking one that's 2 away. We need one of the ones at least that's 2 away to be a 6, but we don't know like which one's going to be a 6 like right off the bat for all of these, right? Or whatever the digit is. So hopefully that you get that. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I think the 11s and 10s are the place to start. The 11 especially. 11 is 5 plus 6. I think we can never put a 6 in any of these cages because we can't go 6 away. We'd be off the grid because we go 1, 2, 3, 4, 5, and then where would we go from there? So I think we have to put a 5 in this 11 cage, and that means there's a 6 in one of these 2 cells, which I'm going to sort of highlight in green and put a corner mark 6 to try to remember that that's what that means. Maybe I'll green it with this one. So how about the 10s? So 10 is 6 plus 4. So both 10s are going to need 4s in them because we can't put 6s in any of these. But we're going to need a 6 4 away. So that's going to be a 6 here or here. Interesting. So that actually does make corner marked 6s here. The 4 wants a 6 here or here, and the 5 wants a 6 here or here. They can't both be in the same box. So we end up with these pointing 6s. Put 6s over here. Okay, we can't put a 6 in a cage, so there's going to be a 6 here. Okay, what else can we do here? Oh, this 10 cage needs a 6 4 away. Here or here. Oh no, wait, hold on. Yeah, so this is not a 6, so this 4 needs a 6, and that's going to be placed here. Yeah, that's going to be placed there. Okay, that's nice. So now these 6s look in. Can't put a 6 in a cage, so that's a 6. And then these 6s look in. I guess there's just a 6 over here. That's not that helpful. All right, so the ones that are more central, like this one, this can't have anything bigger than a 3 in it. And we need to do 3 plus 6 or 4. We can't do 4 plus 5 because we can't be 4 away. So this needs to be 3 plus 6. We need a 6 3 away. The column already has a 6 and it's not 3 away. So the row needs to provide it, and this is the only place for it. So that does give us this 6, and it gives us this 6, and then we can clean up our colors here. Very nice. Okay. We have a 3 over here, which means we need a 3 up here. We can't actually put a 3 in a 6 cage because we need another 3 in the row or column to add with it. So this is not going to be a 3. That's a 3. Similarly, we can't put a 4 in an 8 cage, which we should maybe use. It does mean there's a 4 in one of these two. If this was a 4, the only thing we could do is put a 2 here. That actually seems viable. Okay. How about this box? It has 3 digits left. We need a 1, 2, and 6. We're not putting the 6 in either of these. Actually, the 6 is just placed in the box. There we go. We're done with 6s. This is a 1, 2 pair. So 2 doesn't work. Oh no, 2 does work. 2 just works itself out with the 4. 1 would need a 5 here, or a 5 here, or a 5 here, and that doesn't work. So this is a 2, and it's done. That's a 1. We need a 1 here, and then we need 2, 3, 5 here. Okay. This could still do 4, 2. I'm thinking about this column. just filling it. So, because this can't be a 4. Again, because we can't be half the number. We need 2, 3, 4. That's it. So this can't be a 4. Now, can this be a 2? If we put a 2 here, we would need a 4 here or here, and that would put a 4 in an 8 cage, which we can't do. So we can't put a 2 in the 6 cage. 3, we would need another 3. Again, you can't be half the cage. Okay, I just said that, and I put a 3 in here anyway. But anyway, this is a 4. The only cell that is 4 away from this, we can't go vertically, so the only cell that's 4 away is this one, and we need that to be a 2, which we said was probably going to happen. These 3 are 1, 4, 5. So the 4s are here. The 2 in this box is placed. 3 is in one of, oh, 3 is placed. Oh, that's nice. Okay, so we need a 5 somewhere. So we could put a 5 here or here. I think either one is viable. So let's actually green this so that we remember that we need a 5 in one of these two. We'll corner mark that again. Oops, I didn't mean to purple it. I meant to corner mark it 5s. The remaining 2 cells for this row are the 5 and the 1. Makes sense? The remaining for this row are 1, 5, and 4. 4 is placed for the row. Okay. How about this 8? So yeah, we can't use it. We can't use a 2 because the 6 and the 6 are already placed in the row and column, and they aren't 2 away. So this needs to be a 3. And that's going to put a 5 here or here, and that's not a 5. So that places this 5. Gives us the 1, 5, 1, 4, 5. Okay, that green is done. It got its 5. And now we just finish. Cool. So this column needs a 4, this column needs a 1, and we need a 2 and a 3 in this box. That goes here, and we're done. Very nice. Cool. Nice puzzle, Palfly. Good introduction to the, whoopsie. Oh, I solved it again. All right. Nice introduction to the remote sums constraint. I actually haven't done this one before, so very interesting. Yeah, I think there's some key deductions about it. One is that you can't put 6s in any of them because 6 is just too far away. And the other thing is that you can't put half the value in the even numbered ones, which was also very important. So yeah, let me know how you did on this and if you enjoyed it. And of course, if you did, why not leave a like, subscribe, and a kind comment below.